It is. And Brian says he got it. Okay. So unfortunately, Brian, your 2 questions did not make it to the recording. I forgot to click on Start Broadcast. Okay, another other questions? All right, Brian. Let's give it a try. That's a good idea. We'll wait a few minutes. He's going to try to hook up again. It's interesting, Patrick, that both his questions were on the first lesson. Okay, I'm going to switch over to the other. Hey, Brian, I see you.
Am I on now?
You are on. Hey, this is even cooler when we can hear and see you.
All right.
Did you want to ask any more questions, Brian?
I got 35 now. I didn't have the last part of it right. I did
that last connection.
Yeah, I did it a little differently. I did the parentheses first, the PQ, and on your answer you had true, false, true, false. I had true, false, true, true. If you look at the
I've got it up now, Brian.
Yeah. The negation of P
and Q.
I did the negation like you did of P, F, F, T, T. And then for Q, maybe that's where I made my mistake. I had under Q, I had F, F, T, F.
Oh, yeah. The first entry for Q.
Oh, no, not over there, but the far right-hand side, yeah.
Oh, so instead of copying it, you had, I see. Okay.
I had F, F, T, F under Q. Maybe that's where I made my mistake.
It looks like it is, because it's supposed to be TF, TF.
So the correct process, the first set of parentheses, I get that. The second set of parentheses is where I made my mistake.
You know what? Maybe I should have drawn in the details here. Here's how I would have. I'll draw them in here. So let's put the not P right over here.
That's FFT T.
And then let's copy the Q column.
That's where I make my mistake.
Okay.
So all you're doing is copying.
Yeah, I'm just taking this column and duplicating it.
Yeah, that's where I made my mistake.
That's all it takes. Yeah.
That's the difference right there.
Okay. Good. So you knew the rule. You just had some incorrect letter there. Yeah.
Right. So when do you just bring it over like that? Do you always bring it over for every letter?
When I did it, I did them over here. I just left them here, and then you kind of point to them with your finger. But if you're gonna bring everything over to the right, whenever there's a letter with just no negation on it, then you basically just copy it.
Just copy it. Okay.
Yeah. Let me do that on the first part too. Then this should have looked like in blue. And then Q just stays the way it was. Well, I could have done it over here. There's different styles. it clogs it up a little bit, but I maybe put some lines in there too, like so that otherwise, it starts getting a little bit clogged up. Anyway, you can either leave them over to the left or you can bring them over. And I guess bringing them over makes the vision easier. So.
Okay. All right, that makes sense now.
Did you want to look at any others?
Let me see. I think I'm good on 3.2.
You mean 3.3?
That was 3.2.
So these were all 3.2 questions you were asking me.
Right, right. I'm good with.
Oh, you're saying that's it for that one. Gotcha.
Right.
Boy, slow. So let me get 3.3 ready just in case. And we're going to be going there anyway. So. Patrick, did those problems we went through make sense?
Yes.
Okay. Still no sign of Valencia tonight.
In exercise 3.3,
Yes.
the word then, that means a negation? Is that correct?
No.
Or it's always not. Not is the negation, right?
Right. When you see a then, you should also see an if earlier in the sentence.
Right.
What that's telling you is that's an if-then statement.
Right, and the if-then statement is a conditional statement.
That is correct. That's the one that's, what, only false?
When the first statement is true and the second is false. Okay.
Yep.
All right.
Yeah, if you see the word not or isn't with a contraction, that's the only time you would want to use a negation.
I was hung up on question 29. If the temperature is above 80, then I will go to the beach.
Okay? All right, so here's 29. So the first thing I did is I symbolized it with P and Q. So, in other words, P stands for, hang on a minute. Yeah, so this right here is the original statement. If the temperature is above 80 degrees, then I will go to the beach. So I just called it AB. You could call it P if P. I guess I should have used PQ if I'd have followed directions. Okay. So then it says, write the corresponding statement in words. Let's see, write each statement in symbolic form using not and or. Okay. Now, I don't know if we went through this or not, but there's an important fact here. And it's in a hint somewhere, and I don't remember where it is. But here, if we have if P then Q, that's always equivalent to not P or Q. This is this is an important fact that will always be true. This is kind of like a theorem or a rule, something that's always true. So what they were asking you to do in the second part is to rewrite if A then B using a not and an or. So do you see what happened here? You take the first statement and you not it, and then you inclusive or it with the second. Uh,
So
and I don't remember if I taught that or not, but it's very important. So yeah, go ahead, Brian.
so would it be correct to say if the temperature is not above 80?
Yeah. Here's my translation. Correct. Not if. Now it's an or statement. See that? Now it's an or. So you say if uh, the temperature is not above 80 degrees, or I will go to the beach.
I got hung up, I guess, on the English part of it. It didn't make
Yeah.
sense to me, or I will not go to the beach.
Or I will go to the beach.
Yeah, I had the temp is not above 80, or I will go.
Yeah, that's correct. That's
Or
actually correct.
okay,
That's correct.
that's correct then. Okay. Yeah, just the English seemed a little funny. Let's
Yeah,
see.
the exact. I mean, there is no. There's probably about five or six. We're not being fussy about the English, but yeah, you did it correctly.
Uh,
So, Patrick, did you get this box thing down here? This is really important for you too.
Actually, no, not so much actually.
Well, you need to. What I mean is, you need to put this in your notes.
Oh, yeah, I got it. That way, I got it. Yes.
Okay. Yeah, I maybe don't understand it, but this is an equivalence, which means this will always work every single time. So that's why I put a rectangle around it. It's a biggie. You're going to have to know this by for the end of the chapter.
so the definition of that, you would say it's the same or
They're equivalent.
they're equivalent. Okay.
Yeah. Which is in effect, Brian, means the same.
Okay.
So you were right.
All right. One other one, I guess the wording a little bit on 39.
Okay. All right, number 39. Let's see. What are we supposed to do in this part?
Let's
In
see.
35 to 39, use, let's see, all even numbers are divisible by 2 can be translated. Oh, you're translating into an if-then statement. I got it. Okay, so all rectangles whose diagonals are perpendicular to each other are squares. So all that is if you have a rectangle, so if you have a rectangle, whose diagonals are perpendicular,
Then it is a square.
right?
No, the book gives you a little different wording, so
Then, oh yeah, then you have a square. Yeah, there is no exact one way to word this, but in the if part you have to have the rectangle and the diagonals being perpendicular, and in the then part you have to have that it results in a square.
okay.
And there's still probably 1,000 ways to say that grammatically, but that's what we're looking for. Biggest problem students make is that they switch the if part and the then part. So that's what's more important here, that you have the right things in the if part and the right things in the then part.
Could we go over 41?
You bet.
And I think that do it.
Yeah, here's 41. Okay.
I got P, I got Q, got the negation of P. P.
So the negation of if P then Q is equivalent to Pn not Q. So do you see how I translated that in the box here?
Okay,
Does that make sense, first of all?
right.
Okay. So then all I did was bring the box down here, and I started making a truth table. Because we only have 2 letters, we only need 4 rows.
Again, you start off with the negation of Q right next to Q.
That's the way. Instead, again, I went back to that other style. Instead of putting them underneath, Brian,
Yep.
I left them over on the left, and then I actually take my fingers and point at them so that I'm, yeah. But you can certainly bring them over here. That's fine. So yeah, because I needed a not Q, I stuck that in right away, the opposite of Q. And then I started, this is the final answer, but I started with this right here. If P then Q. So I looked over to the left, and when is the only time an if then is false is when the first one is true and the second one is false. That's second row.
Okay,
So in this column,
got that.
that's the only one. All right, cool. And
And
then,
right next to it, you write the negation of that.
yeah, and I decided to stick it right under the negation. I thought that would be easy to see. So
Right.
all I did was just take the opposite, and that gives me FTFF. So that's kind of my answer on the left side.
Okay, with you there.
Stop, go over and do the right side. So now this time I have to do P and not Q. So Brian, over here I'm putting asterisks above the P column and the not Q column.
Uh-huh.
And then I'm ANDing those 2 columns, and that rule is what? Only true when both are true?
Let's see here. Only true when both are true, correct.
So here we go. True, false. They're not both true. So that's a false. Back over to the left. True, false. They're not both.
True.
I forgot what. True, true. Excuse me. I looked in the wrong place. True, true. They are both true. True. False, false. They're not both true. False. And false, true. They're not both true.
Okay.
So now I put an arrow there. That's the answer on the right side. Then just compare the 2 arrow columns. And you notice they are identical.
Yep.
So we've done it. We showed that the 2 statements are equivalent.
Uh,
The whole idea of an equivalence is to show that the truth tables come out the same. And because our 2 arrow columns are identical, that does it. That shows that the 2 sides are equivalent. So I could maybe write on the bottom, therefore, equivalent. And that's what we were supposed to show.
all right.
Okay? It sounds like you're a little fuzzy on that yet.
I just I did it a little differently, but your way is a lot easier when you do the negation right next to the PQ.
Okay.
It makes it a lot easier. Okay.
Okay.
All right.
So any more questions?
It's the last one I would have would be 45.
All right. We're going to have to do that one. That's fine. Okay. Okay, number 45.
Again, we're doing negations.
Yeah, it says in 42 to 47, write in words the negation of each statement. Okay, so first, I'm going to just symbolize this, okay? If I kiss you once, then I will kiss you again. That's just my strange letter abbreviation, okay? If I kiss you once, then I will kiss you again. Okay, what's the negation of that? Well, here's the tricky part. You got to think in an if-then statement, what's the only time that it's false?
When it's not true.
Well, when the first part is true and the second part is
False.
false. So what I'm going to say is, well, here first let me abbreviate it first. Okay. So in other words, the first part is true. So I kissed you once, and I did not kiss you again. So I kept the first part true, kissed you once, and I made the second part
not true. Okay.
Yeah. And then just write that in words. So I kissed you once, and should I just say not again?
Okay.
Now the book probably has slightly different words, but
Right.
it should be the same concept. So what made that tricky is we didn't talk a lot about the negation of an if-then, but if you just remember that an if-then is only false when the first part's true and the second part's false, okay, make the first part true and make the second part the negation.
Okay. All right.
And then you'll have it. Those are good questions, Brian.
Okay, I'm good.
All right, cool. Patrick, thanks for waiting that out. I hope you got something out of that. Okay. So, new lesson. So, first, I have this is kind of an interesting courtroom example. See if you can concentrate real heavily on this and see if you can get what's going on here. Okay? So, I'm starting you got the picture, and I'm starting right at the bottom of the picture here. The field of law requires the ability to apply logic to do reasoning and argument. So, here we go. We're in a trial, okay? A man was being tried for participation in a robbery. And here's the partial transcript. Okay, you know who the prosecutor is, right? That's the lawyer trying to nail the guy and make him be guilty. And he says, if the defendant is guilty, then he had an accomplice. And the defense attorney, that's the guy trying to protect the the accused guy, he says that's not true. Is that Valencia?
Yeah.
Hi, Valencia.
Yep. She was on. Now she's off.
Okay. Well, anyway. Okay. So right at that point, the judge, who was really on top of his logic, said, I declare a mistrial. You get what happened here? All right, check this out. The prosecutor says, if the defendant is guilty, then he had an accomplice. And the defense attorney says that's not true. Okay, now this is an if-then statement right here, right? Does everybody see this is an if-then statement?
If
Here's
that.
the if part, and then there's the then part.
Right.
When is the only time an if-then statement is false?
The only time it's false is when the first statement is true and the second statement is false.
Now look at the first statement. If the first part is true, what did the defense attorney just admit?
He said it's not true.
He just admitted that the guy he's defending is guilty. Do you see that? Because remember, the only time an if-then statement is false is when the first part is true. Do you follow?
Say that again.
Okay. When is the here?
I get the if then.
This is like if P, and over here is the then Q.
Q, right?
Okay. Now the defense attorney says that statement is false. You see that?
I'm with you there.
Okay. Now go back to the first statement. When is the only time that an if-then statement is false?
When it's true.
And the second part is false.
Yeah, and the second part is false.
But look he's admitting the first part is true. And what does the first part say?
Well, the prosecutor is admitting he's...
No, the defense attorney is the one that said it's not true. So he's admitting that the guy he's defending is guilty. Do you see that?
If the defendant is guilty... I don't know why I'm not getting it, but...
I don't get that.
Okay, let me just try and go through this. I'll try to say it more simply again. Again, the only time an if-then statement is false is when the first part is true and the second part is false. So this guy down here that said that's not true, you know, the defense attorney, whoops, great. The defense attorney,
Yeah.
he just said the first part of that statement up there is true. So he just said the guy I'm defending is guilty. He said it indirectly.
How do you come to that conclusion when he said it's not true? He's saying that...
You're not getting the part that the only time an if-then statement is false, Brian.
Yeah.
Is when the first part is true.
Okay.
Look at the first part.
Yeah, that's true.
So he just said the defendant is guilty. I mean, he said it indirectly. He just admitted that the guy he's defending is guilty. And of course, that's a mistrial because the defense lawyer cannot be against the guy he's defending. You're still not seeing it, are you?
No, I'm not, but
well, here's the thing. If you don't get the illustration, you really should, but if you don't get the illustration right now, just remember this. This is what's weird. The only time an if-then statement is false is when the first part of the statement is true.
yeah,
I
know the second part's false, but look at
how do we know it's true? That's probably where I'm confused. How do we know that it's true? The first part is true to begin with.
because he just said that's false. Do you see this right here?
Yeah, he says it's false.
He just says it's false. The only time an if-then statement can be false is when the first part is true. That's how we know. That's the only way an if-then statement can be false.
We're looking at it literal here because, I mean, you know, kind of real life compared to how you're looking at it. Maybe that's the problem.
Real life. Yeah, I guess this actually happened. I guess I don't. Okay, well, I thought you guys would see that, but it should be clear. But maybe if you come back, it goes back to you got to know a little bit about logic, and you guys already know that when you do an if-then statement, when you do one of these, if P then Q,
Yep.
the only time that this can be false is when P is true and Q is false, right?
Right, right.
Well,
So if the defense attorney said that is true, then he would be in line with that statement. Is that correct?
well, I don't know. That's not at issue here. He didn't say it was true.
But
Here's why that's not so clear, because all other three combinations are going to be true, aren't they? Remember, when you do here, let me remind you guys of this. I got to make a new slide here, and I can't think. Okay. Come on, baby. Okay. So when you're trying to do a truth table for this, you know that you're going to have a setup like this. Right?
correct.
And which is the only line of the four that's false?
Second line.
The other, so the point when what you just asked about, Brian, is if he said it was true, does that mean he's innocent? No, because there's still three other cases to consider here. Do you see that?
Okay.
But when he says an if-then statement is false, there is only one possible line, this one. And look what that says about P.
Logically, okay. I see you.
So, I mean, he didn't mean to do it, but he just inadvertently admitted that his client was guilty. And of course, the sharp judge, and they do have to know their logic, said, no, you can't be against your client. That's a mistrial. Anyway, that's just kind of an odd fact about if-then statements. Usually, you know, we have a balance of two truths and two falses, you know, most of those rules. But in this rule, there was only one, in a if-then, there's only one row that's false. Okay, well, I thought that was a pretty good illustration, but obviously I'm going to have to punt on that one and come up with something better.
Yeah, that's still got me there. I hate to say it, but still got me.
I still have you confused too?
That's going to be confusing.
Okay.
I don't know for how long, but right now it is.
Well, you know, why don't we talk about this a little bit more when we get together on Wednesday? I don't know, that may or may not help, but we'll try it. Okay. So, now,
We're on chapter 3-4, right?
yeah, here's your title. So when you're doing your notes, here's your title slide. Variations of the conditional, and you notice I've numbered, it's like a two-part lesson. The first part is variations of the conditional, and the second part is something called implications.
Okay.
So that's all there is to that. Okay, so guys, this is all going to be about if-then statements. So you can see up here on the top, let's just take a generic if-then statement, if P then Q. Let's have that be our kind of our beginning point. If you take an if-then statement and turn it backwards, like I did in the second line here, if Q then P, that has a name. That's called the converse of the original statement.
Okay.
Now, just let me give you an example of that. Okay, here's an if-then statement. If it rains, then the sidewalk will get wet. Okay, what happens if I turn that around? If the sidewalk gets wet, then it rained.
So you're saying the same thing, just a different way.
Nope, it's not. First of all, what do you think about if it rains, then the sidewalk will get wet? I'm assuming it doesn't. The sidewalk doesn't have a roof over it. That sounds true, correct?
Correct.
But how about the second one? Be careful about this. If the sidewalk gets wet, then it must have rained. Oh, what if you had your sprinkler out? Or what if a dog came by and relieved himself?
So
Sorry about the bad example, but do you
you're
see
making
that
some.
just because the sidewalk is wet, that doesn't mean it rained.
Okay. So
So you got to be careful. It sounds like it should work, but so you got to watch out for converses.
there's too many assumptions with a converse.
You can't. That's right. You can't. Don't think that you can just flip them around and make it work. That's not good. That's what this is. Okay. So now, in the first example, we just took the Q and the P and we reversed them. We call that a converse. In the second example, I leave the P and Q in the same order, but I put a negation on both of them. Okay? And that we call an inverse. You need to know these. You need to know these names. So the first one, you just reverse the P and the Q. That's called a converse. In the second one, you leave them in the same order, but you negate them both. That's called the inverse. And by the way, that doesn't work either. For example, if it doesn't rain, then the sidewalk won't get wet. You see the flaw there?
Right.
Because again, it could be the neighbor's sprinkler that made the sidewalk wet. Okay. But now, the last one, we flip the two around and we negate them both. If not Q, then not P. And that is called the contrapositive. And that one always matches up with the original. So let me give you an example of the last one. Back up to our top example. If it rains, then the sidewalk will get wet. The contrapositive, if the sidewalk did not get wet, then it didn't rain. That is true. Right? Because we know if it rains, it's going to get wet. So if the sidewalk didn't get wet, then it didn't rain. So of these...
Or your neighbor didn't run his sprinkler.
No, you didn't hear me. I said if the sidewalk... Well, yeah. But the point is, it couldn't have rained because if it would have rained, it would have gotten wet. We didn't... In this one, we don't need a sprinkler. Do you follow? What we're saying is if this... Here, let me give you... All right, let me get off of the rain. What else? The hard one to come up with good examples for. All right, here we go. If he kicks the ball between the goalposts, then he gets 3 points. Okay, that certainly is true, right? I mean, assuming there was no penalties and all that kind of stuff, right?
Yep.
Okay. Now the contrapositive says if he didn't get 3 points, then he didn't kick it between the goalposts.
Okay.
That's right on. Do you see that?
Sure.
Okay, now let me show you the converse. So if he kicks it between the goalposts, then he gets 3 points. This one says if they got 3 points, then he kicked it between the goalposts. Well, they could have gotten a safety and an extra point. I suppose you can't, that one, that's maybe not a good example. But anyway, here's the deal. This one, the original statement, and the contrapositive, you probably noticed, those are the two that are identical. You see that? I'm going to prove it to you. How can you prove it? We'll do a truth table. And I'll prove to you that always works. Okay, now you guys already know how to do this. Here, let me make a different color here. You guys can see the colors, right?
Yeah.
Okay. So, let's do if P then Q. Okay, when is that? What's the rule for if then?
It's false when the first one is true and the second one is false.
So that's the row that's false. The other three are true. Okay? So, all right. Now so that's our answer on the left. Okay, now let's do it on the right. I'm going to fill this in. Not Q is the opposite of the Q here. So that would be what? False, true, false,
False.
true. And not P is the opposite of this one, TTFF. So that would be
FFTT.
P. Okay, now do the if-then on that. Remember, an if-then is only false when the first one is true and the second one is false.
So
Here's the only one where the first one's true and the second one's false, right?
right.
See how they come out exactly the same? Both sides come out to TFTT.
Okay.
That proves that the contrapositive, when you flip those two things around and negate them, that will always be equivalent to the original. These other two guys will not be equivalent to the original. Okay, now, what do you need to know here? Well, you need to know that the only way to get the equivalent is to flip them around and negate them both. By the way, here's another example. You guys can all relate to this. If you eat your vegetables, then you can go out and play. Okay, here's the contrapositive. If he couldn't go out and play, then he didn't eat his vegetables. Do you see how sometimes that even clarifies it a little bit more?
Sure.
You know how when a speaker wants to be clear, he doesn't just repeat what he said the first time louder. He tries to, he tries different ways of explaining it. Well, a contrapositive is a good alternate way to say the same true thing. Okay. All right. So I just proved this to you, but here it is written in words right here. You might want to write this in your, just write this sentence in your notebooks. Important concept. The contrapositive is always equivalent to the original statement. You guys get that?
Yes.
This is just what it looks like on the, if you ever go and look at the web resources, it shows basically the same thing. We don't really need to look at it because it tells the same story. Now what it does show is the converse and the inverse. Remember how they don't agree with the original? They're both false. They both agree with each other, but they're both false. So that's not nearly as useful. So the contrapositive is kind of special, and it turns out to be very handy. And it's important when you're evaluating the truth, and even like when you're signing legal documents, to know what's equivalent and what's not. Can keep you from getting fooled. Okay, now separate topic. Three other very important items. Okay. Number one, sometimes you will see the words only if, in that order, only if, in books and in texts. Okay. So if you have, like, you can go out and play only if you eat your vegetables, or you can fill in whatever the P and the Q would be. Okay. But what only if really comes out to is this, and the contrapositive is this. The contrapositive of this is good old if P then Q. So the bottom line is, whenever you see the words only if used like that, then you know, oh, that's just a good old if P then Q. I will show, here, let me show you a problem in your book that does this.
So is that the same as the negation of Q, only if negation of P? Is that correct?
No, that would be the converse of Q, only if P. Because Q only if P. So you notice what you do with the words only if. You just replace the words only if with an if then symbol. See that? So if this was Q only if P, then that would come out to Q arrow P.
Sure.
And Q arrow P is what? That's just the converse of the original. They're just flipped.
Why is the negation of Q and negation of P in the middle there?
You can ignore that. That's really what it means. But when you remember, I just taught you that a contrapositive is equivalent. When you take a contrapositive of this, you get this.
Okay.
What I'm trying, when you simplify it, this is the way it comes out. So you don't really need this. I just wanted to show you that that's actually where it goes, but that's the same as this.
It's the same. Okay.
Yeah. Now I wanted to find you one that has only if in it. So just give me a few moments. I should have done this ahead of time. Number 18. Take a look at page 143 in your books. It's on page 143.
Honk only if you love.
Ultimate. Yeah. Okay, you see the words only if again?
Okay.
Now what did we just learn? Only if you can just replace with an if then symbol. So what does that result in? If you honk, then you love ultimate. You're supposed to rewrite those as if then statements. So anyway, I just wanted to show you, you're going to come upon some problems where you're going to see the words only if. Then you know what to do with it. Just kind of cross them out and replace it with, if the first part, then the second part.
Okay.
Okay. Now, number 2. If P then Q are the same guy we've been talking about, can also be stated this way: P is sufficient for Q. So, if I say to you something like, if you get a GPA of 3.25, then you will be on the honor roll. That could also be said this way: a GPA of 3.25 is sufficient to be on the honor roll. So whenever you see the word sufficient, keep them in this, just keep them in the same order. If P then P. So the sufficient guy is the first guy. P is sufficient. And whenever you see the word necessary, that's on the second guy. So Q is necessary for P. So back to our GPA example. If you get a GPA of 3.25, then you will be on the honor roll. The second, number 3 says, being on the honor roll is necessary if you had a GPA of 3.25 or above. So in other words, it's necessary to follow through on the promise that you made in the if-then statement. So all you got to do is remember this. In an if-then statement, the guy to the left of the arrow is the sufficient guy, and the guy on the pointy end of the arrow is always the necessary guy.
Okay.
Could you say that?
Go ahead, Patrick.
Can you say that again, please?
Yes. When you if you look at the illustration, it shows. When you have an if-then statement, I'm symbolizing them here with arrows. The first statement is always the one that's sufficient. That is, in this case, the P. The guy on the pointy end of the arrow is always the necessary one. So you see what this says here? P is sufficient for Q. Q is necessary for P. So in an if-then statement, the first statement is always sufficient, and the second one is necessary. So these three items are kind of important. Let me just review them again. Whenever you come across the words only if, which is a little bit unusual, right? But, you know, it's a little bit unnatural, but you do see it occasionally. Whenever you see that, just replace it with an arrow. When you have an arrow, you know what that means. If the first part, then the second part. Excuse me. So if I said to you, it rains only if the sidewalk got wet. Well, it just means if it rains, then the sidewalk gets wet. So it just replace the only if with a simple if then, keep everything in the same order. If you do, and then number two, if you have an if then statement, the one that on the dull end of the arrow is the sufficient guy, and the one on the sharp end of the arrow is the necessary guy. You need that in order to understand questions that are in your assignment. Okay, well, let's do a little practicing and looking at this some more. Yeah, we already did this up here. I guess we're not going to practice yet. I got this. These are going to be the last things now in this lesson. Okay, so underneath the line, this is, I guess you could say, number 4. Another very, this is, we just did this, so we don't have to do this again up on top. But on the bottom, whenever you see this, P implies Q. This implies, that's a verb. Here, let me just write way at the bottom here. Implies is the verb. The noun of that same word is implication. When you see those two words, here's the deal. For P to imply Q, they're telling you that if P then Q has to be a tautology. Do you guys remember what a tautology is? Or maybe I haven't told you. I don't know. I'm pretty sure I did. Anyway, we'll talk about it. Do you know what a tautology is?
No.
A tautology is when a truth table column is true all the way down for every entry. So tautology is when a truth table result, the whole column, all the way down, is all truths. Okay, and as you know, we haven't seen any of those yet, have we? But it happens occasionally where a truth table, the whole column comes out to true. So if you do an if something then something, and it turns out to be a tautology, this is a huge event. It means that P implies Q. And this is the way you write that. You've never seen this symbol before. It's an equal sign with an arrow on just the right side. That reads P implies Q. We're going to do one. I'll do that in just in a few minutes here. But I want to give you time to write. So what I'm writing, all this stuff down here, this is the symbol for implies. That's really confusing because look we got 3 other things with arrows, and they're all 4 of these are different now. This is if then, this is equivalent, this is biconditional, and this is the new one I'm just giving you right now, implies. So we got 4 symbols that look somewhat alike.
Can you go over the symbols again? The first arrow.
Yeah, this is if then.
If then, yeah.
You've seen this one before. This is when to prove that 2 statements are equivalent. In fact, we used that today twice. And then our last class on Thursday, I showed you this. What's that? That's the biconditional.
Biconditional, okay.
And this is the new one tonight. The equal sign with an arrow only pointing to the right. And that stands for implies.
Implies.
And the only time you can use it is when the first statement, if the first statement, then the second statement turns out to be a tautology. So let me show you an example of that. Okay. Yeah. Okay. So here's the problem. Look at the top. It says show that this thing in brackets implies Q. So here's how I set it up. I got to set it up where the word implies is. I got to put an if-then statement, and then I have to show that this thing turns out to be a tautology. So I set up the truth table. Here's what I want to show is a tautology. The good news is there's still only 2 letters, so it's still only 4 rows. Okay, let's just work it out now. First of all, in the inside parentheses is if P then Q.
Do that one first.
Yeah, because it's the innermost grouping.
And just write everything under P second.
Well, yeah, let's do this first. If P then Q.
Yep.
So the only time an if then is false is when the first one's true and the second one's false.
False, right? Got that.
So then the other 3 are true. Okay, we got that. Now I copied the P underneath the P, which is what you were talking about.
Yep.
TTFF, TTFF. Now we need to, because that's in brackets, I need to do that next. We need to AND those. And only true and both are true.
True and both are true.
So true, true, that's got to be a true.
Okay.
False, true, that's a false.
Right.
True, false, they're not both true, that's a false. And true, false, that's a false. So here's my first intermediary answer right here.
Okay.
I marked that with an asterisk. Okay, now let's copy Q. TFTF. TFTF. And now the last step is to do an if-then. If from this asterisk, then what's in this asterisk. Okay? Okay.
Only false when the first statement's true and the second one is false.
That's right. And do we have any like that? Look, we have true, true. No, the first one's true, the second one's true. That's true. How about false, false?
That's true.
That's true. How about false true?
That's true.
That's true. How about false false?
That's true.
And do you see that we got all truths as a result? That is called a tautology. And because an if-then statement turned out to be a tautology, you know, play the trumpets, da-da-da-da-da, big deal. We have an implication. And and then I wrote, I know it doesn't look like I'm excited, but this doesn't happen very often. So now I can actually use the symbol implies here because we just showed it comes out to a tautology. And I put a couple exclamation points again just because it's special. Excuse me. Got the old throat tickle again. Okay. So that's what I was trying to tell you before. When do you have an implication? Only when, if you test it in an if-then statement, it turns out to be all truths all the way down. Well, you guys know by now we haven't had any examples we've done in this class before tonight that turned out that way, have we? There's none of ours have turned out that way. So I'm just trying to show you that's pretty rare.
Okay.
Pretty rare. And you know what the word implies means, right? You know, if somebody asks you some questions, you might say, "Are you implying that I'm a liar?" Right? You've all heard that. You know what that means. That means is that what you're trying to say? Are you trying to say that? You know, so an implication is a big deal. It's like you can actually draw a conclusion from that. So if you have this thing over here to the left, you're guaranteed to have this baby. So an implication is kind of like a guaranteed result. Okay, that'll take. I know that's new, and it'll take you guys a little while maybe to adjust to that. Yeah, well, these are some examples from the assignment. So if you have your books handy,
Okay.
I see I have number 3 down there. This is just practice in writing things. So number 3, the directions say translate into symbolic form. So it says you have no cavities only if you brush your teeth with clean. Clean being, I don't know, some toothpaste. So what I did is no cavities. If no cavities, then you brush your teeth with clean. Because what? The words only if. Do you see that?
Okay. Only yeah.
See those words? That told me, oh, just leave everything in the same order. Just if the first part, then the second part. Now, you don't have to pick the letters I did. This stood for cavities, and this stands for brush your teeth. The letters aren't so important. Oh, I guess I was supposed to use P and Q, wasn't I? So it should be, if not P, then Q. Sorry. Okay, how about number 4? Again, I didn't follow the lettering. It says having no cavities is a sufficient condition for brushing your teeth with clean. Okay, do you remember what sufficient means?
Sufficient.
There's all these key words.
Sufficient is, let's see, is sufficient for Q.
Yeah, the sufficient is the first guy.
The first one, necessary is the second one.
Right. So in number 4, when it says having no cavities is a sufficient condition, that means the no cavities go in the beginning of the if then. So that's why, yeah, I should have. That's why I wrote it here. I guess I should have used a P, but
No cavities, because that's a negation, right? No.
no. Well, that has nothing to do with it. It's just, yeah. Oh, yeah. Right. That's why I have the no cavities.
Yeah.
Correct. Yeah, that's correct. Hmm. But do you see why that's in the beginning? Because it's sufficient.
Yep.
And then for what? For brushing your teeth. So on the receiving end is B again, or whatever.
Brushing your teeth would be on the end. Okay.
Okay.
Right.
Yeah. So we did number 6 already, didn't we? Didn't we talk about kissing earlier tonight?
It's the same question in the other
Yeah.
lesson.
I thought. Anyway, we can skip that one.
Yeah, question 45 and 3.3.
Okay, take a peek at number 12. Well, no, that's not the one. I'm sorry. 11.
A necessary condition for a stable economy is that we have low unemployment.
And the key word there is
Necessary.
you bet.
So, stable economy is necessary.
No, actually, which part is necessary when you read the
Oh, that condition.
that we have low? No. What's the necessary condition for a stable economy? That we have low unemployment.
Low unemployment. Okay, so that would be first then.
No.
Is that right?
No, that should be second because remember, the necessary part is always on the receiving end of the arrow.
Q is necessary for P.
Yeah.
You don't change it. P always comes first. Okay.
Yeah. And then stable economy. So if I don't know if you're supposed to use P and Q there, but this is how I would do that. So if you have a stable economy, then you have low unemployment. That's what this actually comes out to mean. Why? Because the low unemployment is the necessary. That's the thing on the receiving end.
Right. Right.
Thing, yeah. So this is number 11. Now I wanted to show.
What would that be? What would that be? P and Q? Because I just said my P and Q. I'm just trying to keep up. How would that look? Using P and Q, how would that look?
Well, it depends on what you call P and what you call Q. You'll have to tell me what do you want to call P. We gotta relate it to the sentence.
Well, it had to be a stable economy.
I would call P a stable economy. That's what I would have called it.
Yeah.
Well, then it would be if P then Q.
Yeah.
No, wait a minute.
I have P then W.
Stable economy. Yeah, that's correct. Okay.
Okay.
I'm more confused with P and Q than I am. See, I like the letters to match up with the sentence somehow, but you can do whatever. What do you think you're going to do with number 14, where it says all dogs are canines? Can you put that in an if-then form for me?
All dogs are canines.
I need that to be in an if such and such, then such and such form.
All dogs are canines.
If it's a dog, then it is a canine?
Yep.
It's a dog, then it's a canine.
Doesn't that say all dogs are canines? It sure does. It says if you're a dog, you're guaranteed to be a canine. Yep, that agrees. Good. So do you see we got all these keywords? We got necessary, we got sufficient, we've got only if, we've got implies, big time emphasis on being, you got to really watch for those words because those words tip off, what you're going to do. And then you also got to do some interpretation of English. Let me show you an example of that. Look at number 38.
Black is beautiful.
Yeah, now can you put that in if-then form?
If it's black, then it's beautiful.
That's right. I don't know how to, because those are both B's, I thought I'd write out the words. How about 40? Everyone wants to be rich.
If then.
Yes.
Everybody wants to be rich. Everyone wants to be rich. Oh no, let's see. Everyone wants.
That's a stinker because, like, if you're a person, then you want to be rich. That's kind of what it says.
If you're a person, you would want to be rich.
So if you're alive, you want to be rich, or if you're a person, you want to be rich. Okay, now let me finish that one up. If you're a person, then you want to be rich. But look at what the directions say. Write the contrapositive of that. So now that we have this if, then there's another word that we just had in this lesson. How in the world, what's a contrapositive?
It's the negation of that, so it would be negation R is to the negation of P.
Yeah, it's both a negation and a flip-flop, right?
Right.
You are correct. Yeah. So So 38. What's the contrapositive of that one?
That would be the same deal. Negation of B is to the negation of B.
Yeah, but the trouble is BB.
Yeah, negation of beautiful is to the negation of black.
You got it. If you're not beautiful, then you're not black. Okay. And it's just different directions. When you get to number 31, it says, here we want you to write the converse of each statement. Let's just do one of those. Let's do 31. Okay? So, if an integer is even, I'm going to write that this way. If an integer is even, then it's square, it's divisible by 4. Square is divisible by 4. I don't know. I'll just abbreviate it that way. So if it's even, then its square is divisible by 4. What's the converse of that?
It's square and divisible by 4, then it's a integer.
Then it's an even integer? Yeah.
Yeah.
So a converse is turn them around, but don't negate them. Yeah, you got the idea. You just got a lot to watch out for. None of it's really that hard. It's just, again, it's new. It's new. So anyway, we've done a number of samples. Let's see. Do I have an assignment? We have some. There are some truth tables too. Oh yeah, we should look at this. Turn the page and look at number 4. Look at the bottom of page 144. Okay. Yeah. Well, it's all done, but let me show you what you have to do on that one. So here's the directions. Determine whether the two statements are equivalent, one implies the other, or neither. Okay, so what are the two statements? Well, I've got them up there. Not parentheses, P or Q, and then there's not P and not Q. Can anybody tell me right off the bat what they are? I guess it's easy if you look up at the screen, but that's De Morgan's law, isn't it?
Yeah.
So they should be equivalent. Well, anyway, I did a truth table to show that. So the first statement, after I did everything and negated it, do you see I got FFFT right here? And then when I did the second statement, what did I get? FFFT. So what does that tell you about the two statements?
They're the same.
Yeah.
And what's the logic way to say that? Equivalent. I heard Patrick say it. Yeah. That's equivalent. And the symbol for that is this. Sorry, my penmanship is... Let me do that over again. This is the symbol for equivalent. Right? You guys need to be real good at that. Okay, let's take a look at number 50. This whole section's like that. Well, maybe not. Let's look at 52. Okay, let's do this one. So do you see what the two statements are they're asking us to check out? One of them is P and P or Q, and the other one is just P. So do you see that I have them written here on the top line? Those are the two statements we're supposed to check.
So you do the one in parentheses first?
Yep. So what's P or Q? Well, the rule for that inclusive OR is only false when both are false.
Right.
So TT is true.
True. True, false.
Correct. And now, here, should I copy? I'll copy the P down.
TTFF.
And now you have to combine those two with an AND. Only true when both are true.
So it'd be the first two are true. False, false.
So there's the answer to the first part. And what's P? Well, that's just TTFF. Okay, so compare the two statements. Well, they're identical again, so these are equivalent again. See that? I'm trying to find an example of a different kind here.
I just got a quick question.
Yeah.
In the equations, the problems themselves, the semicolon or whatever, but maybe I missed that. What is that?
That's just separating the two parts, Patrick.
Okay.
So the first part was P and P or Q. That was this guy on the left on the screen there. And then after the colon, that's the second statement, P.
Okay.
So they had to have a way to divide what are the two statements they're giving you. That whole section is two statements. You gotta, yeah. Here, just take a look at this one. This is number 54. Those turned out to be equivalent again. Okay, well, what if, I guess I don't have an example here. What if they don't turn out to be equivalent? Well, what are your other two choices? in the directions it says maybe the first one implies the second, or maybe the second one implies the first, or there's no equivalence and no implication. So there's like 4 possibilities. Either they're equivalent, like all the ones we happen to do, or the first statement implies the second, or the second implies the first, or none of the above. So what are we going to do if they're not equivalent? Here, this one, they come out to be equivalent again. You see my 2 asterisk columns come out exactly the same again? Just look at the answers. You see this? TF, TTTTT. They're identical. Do you see that?
Right.
So what if they're not equivalent? Well, then you got to try finding out if one implies the other. How do you check for an implication? You have to if one and then the other. So if this would have failed, then we would have had to do this. Kind of erase everything underneath, which I'm not going to do right now. You have to take all of this and try if-thenning this. And see if it turns out to a tautology. And if that fails, then you got to go through and turn this crazy thing around and if-then the other way and see if that turns out to be a tautology. And if that fails, then you say none of the above. So these could be rather long.
Yeah, that'll be confusing. Yeah, particularly.
Well, yeah, what they're doing is testing you on 3 of the approximately 7 things we went through in the lesson all at once. Well, okay, I got a feeling I wasn't very clear tonight. Honestly, I tried, guys. I don't know. Here's what the assignment looks like. We eventually have to get to it. 3 through 53, the odd-numbered ones.
Okay.
I see we took a little bit over an hour tonight. Okay. Yeah, go ahead, Brian. You had something to say?
Yep, I'm good.
3 through 53 odd.
Yep. And I'm only doing 1 tonight. Like I told you, I decided not to do a makeup. This was plenty to stomach anyway, so.
Okay.
So
Good.
let's I guess we'll see you next on Wednesday then.
Thursday.
As I did it again. You know, that's why I had to wait for you guys every week. I've had to wait for you guys for.
I could do Wednesday.
You know, I had to wait for you guys for 24 hours. No, I'm just joking. It's Thursday. You are correct, Brian.
All right.
I don't know why I keep doing that. Sorry.
Okay, guys.
Yeah, this other to make it even more confusing, this other class I teach at a different school was on Wednesday night. This week I don't teach that one, but the following week it moves to Tuesday. So my poor mind is all confused. Anyway. Okay, guys. Thank you.
Okay, take care, guys.
All right.
Bye.